Welcome, this is Dr. G, and in this video, we're going to continue on with transformations and we're going to learn something called mapping notation. So once you know about the a, b, h, and k and how they can transform the function, you need to understand how to apply that using mapping notation so you can either graph a new transformed function once you know what the a, b, h, and k are, or you could be giving two functions, one of which is transformed, and you have to figure out what a, b, h, k are so you can write the equation of this new transformed function. All right, let's get started. You got this. Let's go. Okay, so we know the letters a, b, h, and k can all help transform an original function into a newly transformed function, but then how do we actually utilize these letters? For example, the letter a we know is for vertical stretch. So we can say that the a can vertically compress or vertically expand something by a factor of a. Well, what does that factor actually do? How do we apply that factor of a to the actual points so that we can transform the function? And we do that using mapping notation. So let's say hypothetically that there is an unknown point, coordinate x comma y, in the original function of y equals f of x. How does my letters of a, b, h, and k affect that very specific coordinate point of x comma y to make it into a new point? And if I were to do that for every single point on the old original function, I would then end up with a brand new transformed function. So starting with the letter b, we know b applies to the letter x because it's a horizontal stretch. But we also know b is tricky because b is always doing work as a factor of 1 over b. So it's actually the 1 over b, or the reciprocal of b, that we multiply to our x values to horizontally stretch. The letter h also applies to x in a sense that it is a horizontal translation, and we're going to add the h value, whatever it is, onto the x. For the y, it's the same thing. Our vertical stretch letter is the a, so a gets multiplied to our y coordinate, and then we would add the k value to whatever the resulting y coordinate is. The application of the letters a, b, h, and k onto your original coordinate of x comma y, that is known as mapping notation, and that is how we use transformation letters of a, b, h, k practically to solve questions in this chapter. Speaking of questions, there are two main types of questions they'll ask you to do that requires mapping notation. The first one is they will give you an original graph, and then they'll ask you to sketch a transformed version of that graph when they give you whatever the a, b, h, k is. Although they may not give it to you explicitly, they'll give it to you in y equals a brackets f of x in that form, and then you have to first of all extract what a, b, h, k is and then apply it using mapping notation to figure out the brand new points. The second version of the questions they can ask you is a bit trickier. In this case, they will show you both the original graph and the newly transformed graph, but you don't know what the a, b, h, k is, and you have to figure out what those letters are and then write a brand new equation of that transformed function. Let's start with this example, which is the first type of question where they'll ask you to sketch a newly transformed graph when they give you an original graph. So here we have an original graph of y equals f of x, and we can see we're clearly going to mess around with it using our a, b, h, k's because they want us to sketch y plus 2 equals negative 3f of 1 over 2 x minus 1. Well, when we see this, we really need to know what our a, b, h, and k's are, but in this form, we can't. So we got to clean it up. First, we want to move the 2 to the other side. Then we want to make sure there's nothing in front of the x, otherwise I can't trust a minus 1 as my h. So once I've moved everything to their proper places and factored out the half, you should have something that looks like this. And at this point, we would know what is my a, b, h, and k. And the negative 3 in the front should be my a value, the half should be my b, the 2 should be my h, and the negative 2 should be my k. Once you have your a, b, h, and k down, then you want to find a few points on the original function. So we have here point A, point B, point C, and point D. I just arbitrarily use the letters A, B, C, D, but try to use the capital version of these letters because otherwise it might get confusing with your A, B, H, and Ks. Okay, once we have our A, B, H, and K, as well as our points, we can then tackle this problem. First, let's think. Our original function is y equals f of x, whatever that shape was, and we want to transform it to make it look like y equals -3 f of 1/2 x minus 2 minus 2. So we know that any point on the original function would have to undergo our mapping notation of 1 over b times x plus h and a times y plus k. But we know what these a, b, h, k's are, so now we can have a more specific mapping notation to take any point on the original function and transform them into a point on our newly transformed function. So for all of these 4 points on the original function, starting with point A, the -6, the x value of that first point, I'm going to multiply it by 2 and then add 2 to get -10. For the y value of 0 on the first point, I'm going to multiply it by -3, which is still going to be 0, and then subtract 2 to get -2. So now I know that the corresponding point on the new function of my original point A, and let's call that A prime, is going to be -10, -2. We're going to do the exact same thing for point B. The -5, the x value has to get multiplied to the 2, and then add 2 on top of that to get -8. The y value of 3 gets multiplied to -3, and then add -2 to that to get -11. And as you can see, we can do that for all 4 points to get 4 new corresponding points to the old points. Once we have the new points, we can then sketch those new points on the graph. And as you can see, the red is the y equals f of x, which is my original function, and the purple is made up of the 4 new points that I used, and that is the new transformed function, and that answers the question. The second type of question is this one here, when they give you both the original function, y equals f of x, and the newly transformed function, let's call that y equals g of x, and they're asking you, what was the transformation, and can you write the new equation of the transformed function, y equals g of x, in the form of y equals a f of b x minus h plus k? Basically, you have to know what are the a, b, h, k's in this transformation. So we do the same thing as before. We want to figure out the points on the original function and their corresponding points on the new transformed function. On the original function, we have point A, B, and C, and then correspondingly on the new function of y equals g of x, we have A prime, B prime, and C prime. Again, we know that the original function is y equals f of x, and the transformed function is y equals g of x, but they want it in the form of y equals a f of b of x minus h plus k. So we have to do some work with the points that we have. We know, again, that all points on my original function, they will become the new points on the newly transformed function if we were to apply our a, b, h, k's to the x and y coordinates. But we don't know what these a, b, h, k's are right now, so we have to do some detective work to figure it out. What we do know is we actually know the points. We know the points of the original function, and we know the points on the transformed function. The question becomes, how did we get from the original function points to the transformed function points? To figure that out, you want to look for a point that has a 0 for either the x or the y value, or in this case, both. Again, only look at the original points. Zeros in the transformed points make no difference to us. It doesn't help us at all. Look at your original points and see if you have zeros in any of the x or y coordinates. So here we have a point B that's 0, 0. Perfect. It's got 0 for both x and y coordinates. Now, why are any original coordinates of 0 so useful for us when we're trying to figure out our a, b, h, and k? The answer is, if you have a point that's originally 0, look at the mapping notation. If your original x coordinate is 0, does it matter what you do when you multiply the 1 over b to the x? No, because anything you multiply to 0 remains 0. So essentially, having a point that's 0 eliminates any form of usefulness of your b or a values because they get multiplied to your x and y values, which means if your point of 0 then changes to a different number, what could be the culprit of that change? It ain't gonna be B or A, it would have to be H or K, depending on whether you're talking about the X or Y coordinate. So in this case, let's look at the X coordinate. Our original X coordinate in point B was 0. But on the new corresponding point B prime, the X coordinate became -7. What could have caused that change? Again, what X is my X? It is the 1 over B times X plus H. But what did the 1 over B really do here if my X was already 0? Nothing. Which means the only letter that could have caused my 0 to change into a -7 would have to be my H, and we know that whatever the X is added onto H, so how do you add something onto 0 to get it to become -7? You must have added a -7, which means our H value is -7. We have now figured out one of the 4 letters. Now let's do the exact same thing for the Y. Again, our Y is 0 here, but it ended up being 2 on the corresponding B prime point. Again, what could have caused that change from 0 to 2? It sure isn't going to be my A, because my A multiplies to Y to change it, but whatever you multiply to 0, it doesn't change it. So the only way to go from 0 to 2 would be my K value, and we add the K value onto my AY, which means the K value here would have to be +2 to get from 0 to +2. So as you can see, we want to utilize the 0 point so we can figure out what is our K or H or both in this sense, and then we can figure out A and B. So at this point, we don't need all 3 points, and we definitely don't want to use the 0 point because the 0 point will never help us figure out what A and B is because again, A and B gets multiplied to 0, but that's useless. So we can take, let's say, the first point in this case, from A, which is -4, 4, all the way to A prime, which is -8, 10, and we can do some detective work now to figure out what was my A and B value to make those changes happen, knowing that we have an H and K value already. Let's look at the X coordinates first, which means we're going to be figuring out what is our B value first. So our X coordinate went from -4 to -8, and we know the only way for this to happen is through the mapping notation of 1 over B times X plus H. Well, we already know that our original X value was -4, and we know that after doing this mapping notation of 1 over B times X plus H, our answer is -8. So we can actually set this up as an equation. We can write 1 over B times -4, because that's our original X value, plus H, and we can now put an equal sign because we know that has to give us -8 because that is the X coordinate of our corresponding A prime point. And at this point, we know that H was -7. So we can replace that with -7, and now we just solve for B. So that gives us a B value of +4. All right, now let's figure out the A value. And to do this, we have to look at how our Y coordinate changes. So our original Y coordinate of 4 became 10, and it can only do this through the mapping notation of A times Y plus K. Well, we already know the original Y value was 4, and we know the ultimate result is 10. So we can set this up as an equation as well. A times 4 plus the K value should give us 10. Again, we know the K already. We did it earlier. We know the K is 2, so we can write it as A4 plus 2 equals 10. And with a bit of algebra and simplification, we figured out that the A value is actually 2. So now we know the ABHK of this new g of x, but they want us to write it in the form of y equals a brackets f of b of x minus h plus k. So that's what we're going to do. We're going to slot these letters into our y equals the f of x to get a final answer of y equals 2 f of 4 brackets x plus 7 close brackets plus 2. Okay, let's try a different question here. The first one was very easy because we had a point with a 0 for x and y, which immediately gave us our h and k values, and then we just worked backwards to figure out the a and b values using a little bit of algebra and equation. In this case, look at these two functions. Again, our original function is y equals f of x, and our new function is y equals g of x. Same thing, they want you to write an equation for g of x in the form of y equals a f of b x minus h plus k. However, notice in this case, we don't have a point that's both 0, 0 for x and y. But let's figure out the points first. For my original function f of x, I can have these points labeled here, and their corresponding points would all have primes, and they're listed on the right. Again, we need to use mapping notation to work backwards and figure out what my a, b, h, k are. So I know my original points are here, and I know somehow they became the new points on the right. In this case, it's not all bad. I do still see a 0 in one of my original points, point C. Point C has a 0 for the y coordinate, but we don't have any zeros for the x coordinate, but we'll deal with that when the time comes. So looking at the y coordinate, you can see that the 0 became a 2 on C prime. Again, could the letter A have caused that change? No, because A multiplies to the y. Only way to go from 0 to 2 is if we added a k value to that, and the k value would have to be 2. Before going on to figure out what h is, once you know k, we can do a bit of detective work to figure out the a value, because they both apply to the letter y. So let's just take any point here. Let's take point A to A prime, and we'll figure out how do we go from the 4 in the original point A to the -6. Again, it has to be done through mapping notation of ay plus k, and we know the original starting point is 4. We know the end point is -6, so let's write that as an equation. But we know the k value is 2, so let's replace the k with a 2. We solve, and we get an a value of -2. To figure out what h or b is, let's actually take a look at the patterns here. Let's take a look and go from every single x coordinate to their corresponding coordinates on the transform graphs. For point A to A prime, we have -6 to -3, and the only ways you can go from -6 to -3 is to either add 3 or dividing it by 2. Now, I know you might be thinking, what if I could maybe divide first and then add or subtract? Yes, but for this question, it won't happen. I'll show you later on how to deal with those ones. Okay, now let's take a look at the next point, point B to B prime. How do we go from -2 to +1? Again, we can add 3, and now you see there is a common trend here. Look a little step further here. How do we go from point C to C prime? 1 to 4, add 3. 4 to 7, add 3. So it's pretty clear now that all my x values became their new x values by adding 3. It's consistent amongst all 4 points. That means my h would have to be +3 because I'm adding that to my x values. And having said that, you can take it one step further and think, well, in this case, I can't really afford to have any crazy b values because that's going to mess up my numbers. I can only add 3 to it. I cannot do anything else by multiplying it to x, which means my b value should actually be a default, which is just 1. Now, conversely, you can also solve for the b value if you know your h value is 3. We know that to go from, let's say, the first point of a to a prime, -6 to -3, we know it has to go through the mapping notation, set up the equation. We know the h is already +3, solve for b, and it's no surprise that we get b equals 1 here as well. So for this question, we have finally figured out our a, b, h, k's, and we can plot that into where they belong to give us our final answer here. Okay, lastly, let's tackle the trickiest type of questions here. I'm not going to give you an actual question with 2 graphs. We're strictly practicing how we can figure out what our a, b, h, k's are when we're given the points on the original function and their corresponding points on a new function. But look here, there's not a single 0 on my original functions, which means we cannot use our strategy of figuring out a, h, or k first and then going backwards using algebra to figure out b or a. So let's look at the x coordinates first. For all of these x coordinates, let's try to use the method we used last time. Let's look for a pattern here. From 1 to -1, what can we do? We can subtract 2 maybe. We can divide it by -1. But then how do you go from -2 to -7? Logically speaking, off the top of your head, that would have to be subtract 5. Uh-oh, there's no pattern here. And what about 10 to 17? You add 7. Okay, so at this point, it's pretty clear that there's a combination of multiplying, dividing, as well as adding, subtracting here. You can't just only add or subtract, nor can you only multiply or divide because it's not consistent amongst all 3 options. In other words, in this case, we have some type of b value that's not a default, and we also have some type of h value that's not a default. To figure out what my h and b values are, you have 2 different ways to do this. The first way is kind of like a guess and check. So we're going to take all the x values of our original points as the input, and we're going to put all the x values of our transformed prime points as the output. And we know based on BEDMAS, we have to first multiply or divide and then add or subtract. So let's look at the first row. How do we go from 1 to a -1 if we were to multiply or divide first and then add or subtract? Again, just off the top of your head, what are some things we can do? Let's say you think I can multiply it by 2 first. 1 times 2 gives me +2. And then subtract 3, that gives me -1. That works. Okay. And then, can we apply that to the next row and see if it works or not? It does. -2 times 2 gives us -4. -4 minus 3 gives us -7. For the third point, 10 times 2 is 20, minus 3 is 17. So just by guessing and checking, we realized that you first have to multiply by 2 and then subtract 3 to go from all my inputs and turn them into the outputs. Well, the subtracting 3 part, that's got to be my h, right? So my h has to be -3. What about the multiplying by 2 part? That's tricky because what actually multiplies to my input of x? It's not the b value. My b is not 2. It's the 1 over b that multiplies to the x value. So when I multiply by 2, it's actually 1 over b. That's the 2 that's being multiplied. And the b value itself will be the reciprocal of that, or 1/2. Now, if you feel like the guess and check thing isn't for you, or if it's a bit risky or time consuming, I understand. There's actually another way to do this, and this one requires using a system of equations. So let's take a look at all 3 of these points again and see how we can go from the x of the original points to the x of the new points. We know that the only way to go there is to use mapping notation. And since we're talking about the x value, it's going to be 1 over b times x plus h. So let's actually just pick 2 of these points and let's plot them into an equation. Again, we know the original x and we know the final x's. So for the first points of a to a prime, we can set the equation like this. 1 over b times 1, because that's my original x point, plus h equals -1. We can't go any further here because I don't know what b is, so I don't know whatever 1 over b is. And we also don't know what h is. We can't replace it with a number and solve. We can only leave it like this. But we have 2 more sets of points. So let's take a look at the second set of points, or b to b prime. We can do the exact same thing and plug in the -2 for my original x point and -7 as my final resulting x point. Again, we'll leave the b there and we'll leave the h there. All of a sudden, I have 2 equations, which is now adequate to solve for the variables in both equations. Looking at my 2 equations here, we can set this up as a systems of linear equations. Now, first thing is, if the 1 over b is giving you a bit of problem because it's like a fraction, that's okay. We can actually just replace it with like a letter. Let's say 1 over b is z or something. So our equation now gets cleaned up and it looks like z plus h equals -1 for my first equation and -2z plus h equals -7 for my second equation. At this point, you can have 2 options to solve. You can use substitution or elimination method. For this case, we'll use substitution. To do substitution, you have to isolate a letter in an equation. In this case, we can isolate the letters h's, for example, and I'll do it in both equations, although you don't need to do that. I've isolated h in the left equation to make it look like h equals -1 minus z, and I've also isolated h in the right-hand equation to make it look like h equals -7 plus 2z. If they're both equal to h, that means these two have to be equal to each other, which means we can write it as -1 minus z equals -7 plus 2z. Start moving things around, algebra, solving for z, and we get an answer of z equals 2. But that doesn't mean much because we don't care about z. Remember, we said earlier that z was equal to 1 over b. So if z is equal to 2, then 1 over b is equal to 2, which means b is equal to 1/2, which is the same answer we got previously. Now, to look for h, we can still stick with z, because we know z is 2, and we know our 2 equations is h equals -1 minus z, or h equals -7 plus 2z. It doesn't really matter which of these equations you replace z with 2, so let's just use the first equation here. That means h is equal to -1 minus 2, which means h equals -3. Again, the same answer we got from our guess and check method. All right, we know our b and h. Let's figure out our a and k. Again, we can use a guess and check method, but you know what? Let's stick with our elimination or substitution method for solving linear systems. Again, let's look at all the y's on the original points to the y's on the corresponding prime points. we know that the only way to go from the original to the new points is through mapping notation. And since we're talking about y, it would have to be ay plus k. We have 3 points here. We don't need all 3 sets. We only need 2 sets. Let's take the first sets. I like the numbers. We went from 4 to 0. That means the equation would be a 4 plus k equals 0. I don't want to use a second set because we have a fraction of negative 3 over 2. And I mean, you could if you want, but I don't want to deal with fractions unless I absolutely have to. So we'll use a third set of 8 to 1. If we replace that into the mapping notation, we get a8 plus k equals 1. All of a sudden, we have our 2 equations, which means we can now do substitution or elimination after cleaning up the equations a bit. In this case, let's try elimination. In elimination, you want to stack the 2 equations together, and you want to make sure one of the letters is exactly the same on the top and the bottom. In this case, my A's are not, because I have 4A on the top and 8A on the bottom, but my K's are. I have a K on the top and I have K on the bottom. If they have the same numbers, you can subtract, and we get negative 4A equals negative 1. To solve for A, you would just do a bit of algebra here, and we get A is equal to 1/4. Once you know what A is, can we plug it in into either of our 2 equations to solve for K? Absolutely. If you plug in the 1/4 for A, you'll get a K of negative 1, giving us a K value of negative 1 and an A value of 1/4. And that wraps up the video on mapping notations. Keep in mind, once you know mapping notations, you're expected to use it when you learn later functions such as trig or logarithmic or exponential functions, because you'll be doing transformations for those functions as well. If you liked the video, then give the video a like. And if you really like the video, feel free to subscribe and help the channel grow. If you have any questions or comments or topic requests, you can always put it down in the comment section down below.